Hello, everybody, and welcome to today's episode of Anomalous Live with me, Digby Furneaux, and Tom Thompson. Tom, how are you today?
I'm great, man. When's the last time you've heard me say that?
I know. You know what? Every week it's like, oh, God, what's he going to say? No,
oh, man. I just want to get this out of the way, just really quickly, very quickly, because it's our intro. We have a guest. To everybody that helped out with the PC situation, thank you very much from the bottom of my heart. You got me over the line. And to the love of my life at the moment, Miss Gemma, who's been, you. She may be watching right now. I love you very much. That is my girlfriend.
Everybody, Tom has got a girlfriend. Congratulations. Well, look at the smile on his face, Gemma. I don't know what you've done to him, but he's certainly enjoying it. Look at him.
Well, she's been my best friend for the last 12 years. That's what she's done. So, I'm very emotional about it. I'm not going to lie to you. I'm soft as hell over it.
I hope you're not too soft, if you know what I mean. Anyway, moving on. Tom, who's our guest today?
Oh, man, this is a good one. I sent the word out for this one, and a lot of people in our UFO X community are very excited. Our guest today is Mr. Bruce R. Fenton, an author, researcher, and public speaker known for his groundbreaking work in the realms of ancient mysteries, evolutionary science, and anomalous phenomena. Bruce is the author of books such as The Forgotten Exodus and Exogenesis Hybrid Humans, where he presents compelling evidence that challenges conventional narratives about human history, suggesting that our species' development may have been influenced by extraterrestrial intervention. One of our favorite subjects. Bruce Fenton, welcome to the podcast, sir.
He is coming. There we go. There he is.
Thank you very much, Tom. Thank you, Digby. Appreciate being here. And I guess compelling is furthest to decide. I find it compelling. We'll see by the end if your audience finds it compelling.
Fair enough. Bruce, you and I have had sort of a long digital relationship on X, and this is actually the first time you and I are actually like getting to speak to one another face to face. I've always wanted to ask you, just to throw us right into the mix of things, where do humans come from?
Oh, just a small question then, Tom.
Let's just do it.
Yeah, I mean, well, you have to start with the fact that, we give these names to species, right? So we say, that is a tiger or that is a human. So, so we have to decide what is it we mean by that? And that's more complicated than most people realize. So there is an ongoing dispute over what constitutes a human. And so when we look back through the fossil record at the perceived ancestral hominins, you kind of have to say, where do you draw the line and say this one's not human, and this other one temporally close to it is human. I don't necessarily agree with probably the mainstream view that you can take it all the way back to sort of 10 million years ago, which a lot of academics feel. I would take a view which, again, is still within the academic debates, is that probably that Homo erectus is the first truly recognizable human. That, and I always say that if you sat next to a Homo erectus on the bus, you would be frightened and probably would get off. But at the same time, if you saw one in the zoo, you would be looking down and saying, what's that guy doing in the cage? It really is just in that line where, that is a human, but at the same time, it's not like us, not quite like us, right? It's recognizably got brow ridges that are much more pronounced. It's got, structural differences to the skull. The body would be mostly the same. Its height is comparative to average heights of humans today. And more importantly, it's the first hominin that has fully come down from an arboreal state with tree nests. We used to have tree nests, right? So this is a fully ground-based, the behavior is fully human, as well as it looking human. So that is where you can kind of draw the line and say, okay, 2 million years ago, we're no longer really an arboreal creature or part of arboreal. We're not a brachiator, we're not swinging through the trees. We have become recognizably like us. Now, you can certainly put an argument to say that going back to about, Australopithecus, that it's very human-like. And again, many academics would say, the Australopithecines are humans. So the hominins is the broader range of humans. Okay, so that you can take that back to about 6-7 million years ago at the moment in terms of the fossil record. So I'll let others decide. But for me, humans, I would say, is at around 2 million years ago. And very quickly, 2 million years ago, we find Homo erectus is both in Africa, particularly in South Africa. But we also know that, surprisingly, that there are traces of Homo erectus in Europe 2 million years ago, and as well as actual fossils of Homo erectus in Dmanisi in the Georgian Republic at about 1.8 million years ago. So it pretty much appears, across these regions around the same time, and so it's widespread and is ranging far beyond. And we know that within another couple 100,000 years, it's down in Southeast Asia. So it really sort of explodes out onto the world scene and becomes the first global human population.
Wow. That's an interesting broad view of all of that.
It is really interesting. What's really interesting though is obviously the next big question is the leap from that to where we are now, and the fact that evolution shows such a slow and steady progress in the evolution of mankind and other species. Crocodiles were around at the time of the dinosaurs, apparently, and they haven't evolved incredibly. They're not standing around, walking around, using their brains, operating computers, etc., etc. So what made us so different, in your opinion, and where did this sudden growth spurt in our mental capacity come from?
Yeah, for sure. So, I'd say there is something of a leap to Homo erectus. First of all, just clarify that it is a bit of a jump at that stage, and there's changes in the brain. You get greater sort of neurodensity. We have got brain expansion and so, but it's not as pronounced as the changes that sort of precede Homo sapiens. But there is definitely, if you look at the kind of the fossil record and look at the genetics, you'd say perhaps something unusual is happening 2 million years ago. Okay, first of all, but for a long time after that, Homo erectus doesn't really progress in a sort of rapid pace. The tools stay broadly the same. There's a slight increase in the skill set for creating some of these stone tools. And as we pointed out, Homo erectus is migrating, it's moving out, expanding into new territories. And of course, that is a driver of change. We evolve to suit the environment that we live in. So not surprisingly, there's some differences between Homo erectus down in Southeast Asia, in Europe, in Africa. So you'll find some differences. But I think it's generally agreed that Homo erectus is somewhat boring, in the respect that it doesn't make some enormous leap in the following million years, right? It really, if you look at the fossil record, there's no sort of sudden jumps. It's a gradual increase of tool skill sets and behavioral changes. The only thing of particular note is it begins to range across water. And so you find down in, and again, this is so important because we'll come to this, but down in Southeast Asia, you find traces of Homo erectus on Flores. And so Flores is one of the islands in Southeast Asia. So they've crossed from mainland Southeast Asia to the islands. And this is really interesting because for a very long time, it was considered that this was a kind of a geological barrier that we call Wallace's line. So in Wallacea region. So there is deep ocean trenches between the islands. So despite the fact that sea levels have changed, and that there was a point when there was a lot more land in Southeast Asia, but at no stage were these islands, these the central islands, actually joined to the continents, either of Australasia or Asia. There was always trenches, right? So this is why, if you look, you'll see that mammals are mostly constrained to the west, and of course marsupials to the east, with a few smaller, rodents and stuff that have crossed on wood, so there's an acceptance of a few animals. But humans obviously are not as small, we're not a rodent, we don't like to float across on a twig. So it was seen as very unlikely that we could have come across. But then, we found evidence that 1 million years ago, some people made it across, right? And we also found then more recently that there are the hobbit-sized small hominins there, the Homo floresiensis, or some people call the Hobbit people, and that they also are on this island, right? So something interesting is happening at around 1 million years ago. So I say that for the million years previous, not very much exciting, but now we're starting to see something interesting. Somebody seems to be building rafts. Okay, so that to me is a technological leap, an important one, because it now it means that you can range much easier to new environments, right? And then it's down in this same area that we've seen some other really interesting things that have come up. I mean, you're probably aware that they've also found Luciensis is another small hominin that's in the Philippines, and there's also traces of potentially, Denisovans down in these island regions and Oceania. So sometimes I refer to this as kind of like a Middle Earth, that we've got something like 7 different lineages of hominins now that are down across Southeast Asia and Oceania, in the distant past, right? So something interesting is happening here, right? We've got a kind of a sudden flourishing of human lineages. The other thing is that if you go back just a few months, there was a big news story that came out about the 99% loss of human diversity that occurs around 900,000 years ago. Now, hopefully some of the audience would have seen this. So there was a lot of headlines saying, human bottleneck event, humans almost went extinct, and there's a kind of a mystery around, what happened here. Because 99% collapse in population. Obviously, that is dramatic. So now you see something strange is happening, right? Why is the human population almost gone extinct in what seems to be a very short period of time, right? So when you look at that, what you expect to see is something like, evidence of a global, comet impact, or supervolcanoes, or, disease becoming rampant, and you should see kind of a collapse of hominin populations across the world, and represented in the fossil record, right?
Right. Yep.
And so they haven't found that. So that's why this kind of mysterious. Like, well, what could cause this if it's not a global cataclysm, and if you're still finding about the same number of fossil sites as you would in other periods, so there's not an obvious global die-off, then there's only one other mechanism that we kind of understand that leads to these kinds of bottlenecks, right? And that is a split in the population, with one group that is ancestral to us breaking away and becoming isolated. Okay, so it's reproductively isolated. So you don't need all the other groups to die off. It just isn't mixing with them. Okay, and when you look at the world, all of the other continents are joined up, basically, right, where humans live, except for one, Australasia. Okay,
right.
So if you've got hominins now down in this region, we know they're there 1 million years ago, and then at around 900,000 years ago, there is a sudden bottleneck with a 99% loss. That fits very nicely with a group of these people breaking away from the rest of the world as they've crossed Wallace's line. They have now moved into the islands of Southeast Asia, potentially Oceania, which you'd expect to happen very quickly because it's a vast continent visible from some of the mountains of these islands. So you sort of think about it. Why would you do all the hard work of crossing Wallace's line and never voyaging towards the enormous continent just to your southeast?
Right. Doesn't make sense.
It doesn't make sense. And so this is another kind of strange thing you find in the academic literature. They're still kind of saying, well, humans don't arrive in Australia until maybe 80,000, maybe 100,000 years ago, if they're being generous. Some people still put it to 60,000. But it doesn't make sense, because we know that now there's hominins all across these islands that even by accident, some of them should be washed across, right? Particularly if they're using watercraft to cross from Southeast Asia. Those craft should at some time get washed across. I'm sure we've all seen those news stories, fishermen swept from Asia to Africa, or so we know this stuff happens. In fact, they've even said that they think old world apes and monkeys managed to somehow be swept across from Africa to South America. So even monkeys on kind of nets, they think nets of leaves and bushes that were swept away, right? That some of these monkeys survived and were carried across. So if we can accept that for monkeys, surely a higher intelligent species like humans is more likely to survive one of these events, right? So you're swept out onto a log, you catch fish on the way, whatever, and you survive. So it should be expected. So your next question is, well, okay, if that happened, where's the evidence? Well, since then we've lost 130 meters of land, right? Because there's 130 meter sea level rise. So we've lost an enormous, a continent amount of land around Southeast Asia and Australia. So coastal sites of these people will be deep underwater, right? So this is why you get these kind of disconnects. So, well, there's no evidence of these people getting there. But now we're saying there is. It's in the DNA that there is this divergence that we don't see any other explanation for. So this is kind of the reason why I have to cover this quick. I'll let you is you need this precursor that because I'm going to put the important events of this story in Oceania and Southeast Asia. That unlike the mainstream story of nearly all of the key events in our evolution happening in Africa, that I'm arguing that many of them are happening beyond Africa, particularly down in Southeast Asia, East Asia, and Oceania.
Well, it makes a lot of sense, honestly. It's just this breakaway that happens, and I keep going back to that, just mentally, 99%, this bottleneck.
It's an enormous drop.
It does. You know what it sounds like to me? And again, maybe this is just my UFO brain doing this, but it sounds like they were removed. Right? Like it sounds like there was an intervention where maybe something, and maybe I'm wrong. So definitely, correct me if I'm wrong, but it almost sounds like there was something that happened there where it's not like there was a decision made amongst themselves. It almost sounds like it's like, oh, we're taking this lot and we're going to, you get what I'm saying with that, right? It's almost like a genetic experiment of some kind, honestly.
Yeah. I mean, you can explain it by, interventions of some sort. But like I say, you can explain it with just simply, a lineage breaking away and it's just reducing up. But it has to be that, we're talking about a small group of people. So, sort of, I think they did this sum is about a couple of thousand or less than 2,000 people are involved in this. So in terms of reproductive pairs, so it's a pretty small population, right? So it's broken away. And so all the other people are still out there, but they just can't mix with them. So that would look like that. So it would look like a cataclysm, or it would look like isolating people deliberately.
Yeah,
so again, taking people and putting them in a lab, even if you were to try and do this, it would look the same, right?
Right.
So it'd be very hard to then to distinguish, is someone deliberately doing that, or is it just happening? Because you see is the genetic, the drop in the genetic.
It's just
variation.
so weird. It's just it's for it to be that dramatic, it's like, what the hell is that?
Right. And the other thing is, if you're going to say that this has an explanation in terms of global events, you really got to look for a cataclysm.
Right, and we're not seeing that, right? That's what you're arguing. There's nothing there in the fossil record to suggest that anything was happening on Earth that you would expect to see for this.
No, and
sorry,
the other thing as well is,
just repeat what sort of time frame was that you were talking about?
So this is close to 900,000 years ago,
right?
And the other thing you'd expect, of course, is an impact on other life. Like if you've got the kind of cataclysm that takes us down,
of course, you'd see it in everything,
right? Yeah, why isn't there dropping all the other animals reproduce? Why isn't there plant life being obliterated? Why isn't something else happening? Why is it just us? So that's why I say that this fits best with a splinter in the population. So this puts potentially a small population of humans down in Australia and Island Southeast Asia, right at a key time in our development, because we know that when you look at the fossil record, this is not new. You look at the fossil record around 800,000 years ago, there is a sudden acceleration in cranial capacity in the human lineage, right? Yeah. So that was known before we had any genetics. We just knew that, looking at the skulls, there is this sudden acceleration that is not explained. It's not, unlike previous changes in skull size, it's not linked to body size. So this is what makes it strange. So, if you look at the earlier hominins, they're basically like chimp-sized. The Australopithecines, they're these like chimp-sized humans. So as we become kind of Homo erectus, and it's assumed that Homo erectus is most likely our ancestor, because we haven't found a better fit. It's not genetically confirmed. But so if you look at Homo erectus, we can see that the brain size increases are accompanied with body size increases. Okay, but you get to 800,000 years ago, and then suddenly this chart just goes almost like vertical. It's kind of a crazy increase in cranial capacity. So for a very long time, all we had was these fossils telling us that there was something that happened. And of course, as we moved into the genetic revolution, we've been able to go in and say, okay, well, what is accompanying these changes? Why is the brain size changing? Is there anything else other than size that's different? Right. And like with the full mapping of the genome, and of course with recovery of genomes from extinct hominins, our cousins, Neanderthals, Denisovans, and other sort of ghost populations, which we only know from the genetic record, we don't know from fossils, called them ghost populations. So by looking at all of these genomes, you can start to say, okay, well, we can see that there are a number of interesting changes that are occurring that would impact the brain. And we'll go into some of those. But so first important thing is that gives us a date, and we know that something strange is happening. So if you think about it, we've now got a date of around 900,000 years ago, when there is a apparent collapse in the population down to one small group. And then we see in that small group, within about 100,000 years, there is a sudden change, which gives them a much larger and more complex brain. And again, this seems to be a fairly sudden change. Although it continues to occur, we can see that on the chart, it has a fairly sudden change at that point. The other thing we know is that happening around 800,000 years ago is this is also the beginning of this split between the ancestors that directly lead to modern humans and the ancestors of Neanderthals and Denisovans, right? So these are the other large-brained humans. Now, there's a bit of a disagreement how to group Neanderthals and Denisovans. I'm in the camp that would say that they are Homo sapiens Denisova, Homo sapiens Neanderthalensis, Homo sapiens sapiens, or I would actually probably were today Homo sapiens modernus, really, which is a kind of a hybrid of the survivors of many different lineages, because we have Neanderthal and Denisovan DNA in people today. So, but we do know that all of these large-brained humans are coming out of these genetic changes that occur around 800,000 years ago. And we know that they have the same chromosomal fusion event preceding this. So you've got the fusion that leads to chromosome 2, right? I mean, a lot of people in these topics, in say the UFO aliens, kind of will have heard of at least somebody positing that chromosome 2 is an artificial change that leads to Homo sapiens. There's quite a few researchers have said it over the years. I'm sure anyone watching Ancient Aliens has probably seen it mentioned at least once. And one of the interesting things about that is that, yes, it is peculiar. And one of my colleagues, she's weighing up writing a paper on this, but is still concerned about the impacts on her academic career. But says that there is no strong evidence to put this down as a natural change. That there are elements, right? That there are elements. So as a biologist that kind of collaborate with, that there's no strong evidence that this is a natural change, and that if to argue that would be, she says, incredibly difficult, because there are elements to this that are anomalous. Now she could probably put it better than I can. But what I can say is that the interesting thing about this is that we've also found that chromosome 2's fusion, right, occurs at around this time, around 800,000 years ago. So that wasn't known for years and years. So people would just say, chromosome 2 looks really weird. The creationists were using it to say God came in and changed us. And, Ancient Aliens, people were saying, it's evidence aliens came in. But what no one really had was a fixed date. Okay, because they knew it happened sometime after the split from other primates, 7 million to 10 million years ago. And it happened sometime before the split with Neanderthals, or around that time. Okay, so there was a kind of a really big gap of time. In the last year or so, they've managed to get this down to where they think it's actually occurring in this same period that we see the bottleneck. So somewhere in that 900 to 800,000 years ago, that we are getting the chromosomal 2 fusion event. And again, remember, we've already got the fossil record telling us there's something weird has happened, that we get this sudden acceleration. Now we find that the chromosome 2 fusion event seems to be part of that change. And alongside that, we know that multiple hominin lineages are coming out of this strange change. And this is not the only bit of genomic data that we find. So I'll take you into some other elements, but I'll let you respond to that, because I may not have covered all the bits that I should for the audience. So
Tom,
I hadn't heard this before. I know, but it's just I've heard of chromosome 2, being a very avid viewer of Ancient Aliens since I was a kid. But one thing I'll say too is that your colleague, God bless them for having the courage to even consider doing this, and it's a shame, because I feel like some of the answers are probably behind that wall, where there is still an enormous stigma in the scientific community to go in this direction. But that's a strong argument to make. It's like, hey, we're trying to look at this from the standpoint of how this would occur in nature. And then when we look at it, it's actually complete opposite of what we're supposed to act like that just isn't there. It's not happening. So that's what kills me, is that I feel like if you took that down, we would be so much further down the line with this conversation. Probably years ago, we would be, you know, God knows where with this. And so, all right, I guess my actual specific question for what we're talking about this. So you have the sudden change, the bottleneck, and then you have the chromosome 2 event. How close and how accurately have we gotten the date down as far as like how long? Because I'm curious, like how long did it take for that to take place? Maybe not even necessarily the exact dates, obviously, it's gonna be, but how long it took to happen is probably interesting.
Yeah. So on the one hand, now when we look at the dating for the divergence of these different large-brained humans, right? So Neanderthals, Denisovans, other unknown, other unnamed groups. What we do know is that date has been pushed further and further back. So if you go back, even say, I think 10 years or so, you'll find that it was thought that Neanderthals broke away about 400,000 years ago, something like that.
Yep.
That after discovery of the Denisovans, this date was pushed right back. We found that it had to be at least sort of 600,000 or more. Then there was sampling done from a hominin population found in Spain at Cima de los Huesos, or the Pit of Bones, where we've got the oldest human DNA that's ever been recovered, right? So that turned out to be a population of early ancestral Neanderthals. And so the dating on that was 500,000-year-old DNA. And so they thought, well, the fact that these are already Neanderthal ancestors and are not ancestral to modern humans means we've got to push that date even further back. And when they then contrasted this with the Denisova genome, they realized that actually you're looking at divergent events somewhere around 750 to 800,000 years ago. Now, looking at the fossils, some scientists have tried to push that a bit further, maybe to 850, 900, but most of the data indicates a split 750 to 800,000 years ago. The chromosome 2 paper that I saw where they're tying in the same sort of time, again with a window of error, it's about 850 to 800,000 years ago. So again, there's always a window of error on these kind of genomic studies, as there are in most geological studies. So you never get, I'd love it to be that was, within a 5-year error range, but the technologies are not there yet. So so we're talking about within a, range is usually something like 50,000 years potential, give or take kind of figures. So, but they both are fitting in, closely to around the 800,000 years ago. And again, remember, that's where the fossil record shows us. And so we've got the split, the fossil record. Now we've got the chromosome 2 very close to that date, and as well as this other precursor event not long before it, with this collapse in the population. So they're clustering at just before 800 to around 800 to 750. So all of these events are within that error range. So the other thing that we have here is, of course, is that there are more things happening in the gene. Very quickly, I should say on chromosome 2 as well. Some of the things that are interesting there, you've got the fusion occurs on an active gene, which again, that's considered to be unusual. Some of the changes it gives us are key towards brain changes, our immune system, our reproductive system. Again, systems that you might want to get at if you are changing us. There is genetic information that seems to be added and deleted, and that's when you compare it to the chromosome 2, the ancestral chromosomes seen in other primates. So again, other primates have the extra chromosomes, right?
Did you say added and deleted?
Right. Yeah. So when you look at the ancestral chromosomes in other primates and can compare it to ours, to where we've had this fusion, there seems to be some information loss and information gain around the fusion. So that again is peculiar.
And that's at the same point in time.
Yeah. So this is actually what it's doing to us. So it's having a benefit to us. The other thing about that is, when you have a chromosomal error, so if the chromosomal errors happen, we all know maybe somebody in our life somewhere that's had a chromosomal error, or someone in their family. Usually these are a problem. If they're not a problem, at best they're neutral. And what will happen is it will, through future reproduction, that will fade away again, because either the person won't be able to have children, or if they have children, it's a recessive problem. And the next generation won't have that error, right? So you can say that's evolution kind of sweeping away these errors, right, over time through either infertility or the fact they're recessive. So the weird thing about this is that in our case, chromosome 2 seems to confer extraordinary benefits rather than being a problem, right, or being recessive. And the other thing is that if you think about it, if one person had this chromosomal 2 fusion event, okay, just one person in the population, and they are reproducing within a population where no one else has it, it should vanish very quickly, right? Because it should be just swept away. It should be recessive. Everyone else has got the other old number of chromosomes. And the other thing is, if it was a problem, again, they would be reproductively at a negative and be less likely to have as many offspring, if any. And again, it'd be swept away. So when they kind of the academics were looking at this, they said, what are the constraints around this becoming a fixed change that would spread in a population to the point where you got to remember that we now have a species on the planet where all the humans have this 46 chromosomes rather than 48 chromosomes. All the primates, they still have 48 chromosomes. So, but we know all these other humans that were around, they've been replaced. Right? So there was some benefit to having this chromosomal fusion. The other thing is, it means that initial population had to be fairly small and it had to be reproductively isolated, and the changes had to confer such a benefit that it would continue, and more than one person would have to have it. That these people have to be breeding within a population where multiple individuals have it. What's the chances on a super unlikely weird chromosomal fusion?
There just is.
Right. It shouldn't be happening in a whole group of people at the same time. And it shouldn't be beneficial. And so that's where you start to get to, does this sound like a lab setting? Because now you're talking about an isolated small group of people who all have a strange change at the same time and are interbreeding with each other. And soon after, we see multiple new lineages of large-brained humans being thrown out, like in an experiment. So even in the way it's described in the literature, you think, that's kind of like how we would have some rats in a cage.
Absolutely, 100%. That's all I'm hearing this whole time you're talking. I'm like, this is an experiment. This isn't it. Like, it just, and maybe, and again, and if I'm wrong, I'm wrong. But like, I'm no scientist. I'm no academic. Technically, I'm just someone who likes to think about these types of things. You are even probably way further ahead as far as knowledge on this. But this really, I don't know how else you can hear this and translate it that way. I don't see, and especially in the face of the rest of the genetic information that we have for all of human history up to this point. There's been new advancements. AI is probably going to show us some things that we're not ready for, obviously, with computational power. But I got to be honest, I'm a little blown away right now because I've been aware of a lot of evidence, but some of this is new to me. And I'm kind of like, whoa, this is crazy.
It gets crazier, but I'll let you answer a couple of questions.
I look forward to that.
This leads on really nicely to a project that Tom and I are working on.
It does, doesn't it?
It's one of the reasons why I thought we should have Bruce on. And Bruce, you and I were talking briefly. I put a post out, I put a trailer for our new documentary that I will show you all shortly, because Tom and I are working on research at the moment for a feature-length documentary. Actually, it's going to be our first feature-length documentary about the Anunnaki and man's origins, which lead us really nicely into what you're talking about and similar timelines. I put this online. You said you wanted to speak to me and hoped that I would listen to your side of it and your beliefs into what has happened. I'm really looking forward to hearing that. But first, just to plug ourselves, we will briefly play our trailer for our upcoming documentary.
Awesome.
$452,000 years ago, Earth was a paradise, untouched, unspoilt, and teeming with life. But far beyond our skies, another world was dying. Their heir to turned to poison. Their resources vanished, and their very survival hung in the balance. Desperate, they looked to the stars and found us. So, where are we? We've all disappeared. There we are.
Boy, that was
Bruce,
so
you
cool,
can tell
man.
us everything I've got wrong
Pretty cool.
so far.
No, it looks really cool. That's great.
Appreciate
Actually
that.
great. Like I said, there's a lot of overlap with that story anyway, and so especially visually. You know, we're talking about the same kind of stories. So, yeah, no, it's really cool. And the rise of AI movies, I think, is it's just awesome that people, you know, now we can work from home and start to make, you know, high quality movies. It's just amazing.
Exactly.
100%.
Tom and I are working on now, and it's a really interesting process actually, because it actually really forces you to look at the text, look at what people do, the research, really properly do
100%.
some research, and go, well, hang on a second, what do we see on ancient tablets and carvings represent what actually they looked like, and how much is it based on, you know, things being relative for them at the time? You know, like Tom and I were discussing, Tom was like, well, they didn't actually have wings, did they? That was just depicting the fact that they could fly and things like this, you know, and it forces you to actually start really thinking about it. Tom has been doing an amazing job on this. He's been generating the imagery. I've been running it through AI to try and get it sort of movie quality, motion, and things like this. And we're really starting to get somewhere. But it's the character development and sort of really bringing these things to life is very, very exciting. And it's forced me to do an awful lot of research already into the, you know, I had a loose understanding of the Anunnaki and why they came. And as I posted on X the other day, the more and more I research into it, the more it makes sense for me. It makes sense for me because the fact that there are threads of the story of the Anunnaki throughout all modern day religions. The Old Testament of the Bible is basically a rewriting of the Anunnaki. And just the more I research into it, and then you've got this stuff coming up with Egypt at the moment, and the columns being found underneath it, and then you research the connection between the Thoth and Atlantis, and then you realize that he's potentially Anunnaki, and then your mind just starts going like this.
It's so interesting.
I
saw Bruce, I real quick, I saw, I think it was from yesterday, that you've been keeping an eye on the Egypt thing, and that you are, I don't know, I don't want to put words in your mouth, but you're not 100% sold.
No, I mean, I'm definitely fence sitting a bit on it. I mean, I am convinced that we have an extensive underground complex under Giza. Like I've no doubt in that. I've been to a small part of it. One of my friends is like a lifelong explorer of the underground there. My friend Richard Gabriel, who people can look up. He knows, you know, many of the other kind of like lifelong researchers on the plateau, like I think it's Bill Brown, and maybe I'd have interacted with this team directly because it was him who kind of made me aware of this research before it was online. So he seems quite compelled by what they're doing. So I kind of put some trust into him. And I think that, you know, he probably has a good idea whether or not they're serious people, at least. But the technology, because I don't fully understand it myself, you know, at the end of the day, I'm not an expert on remote sensing, right? So then, you know, what you want to see, of course, is further validation. So the more this technology is used on, say, like known sites where you can go in and confirm what they're saying, you know, it'd be good to see like a wide range of examples where this technology was used on areas with substantial underground, you know, maybe in Turkey, you know, some of these underground cities, which we know are multi-layered cities, right, which also have been accessed by people. So we have some maps and stuff, right? So if you to do this on like Darren Caillou or something, right, and you saw the layers and you saw the chambers, and we were able to then take a map that exists of that, right, and put them side by side and say, okay, yeah, this looks super like the Derinkayu underground city, and then we used it on, a few other sites like that, then yeah, I would be like all in, I'd be like, well,
Fair
obviously
enough.
it's working,
No, you sound just like us, honestly. It's that we sit on the fence and observe and wait to see what information comes out.
I mean, I always go to this point where you see something like this, and like you, Bruce, I'm fascinated with ancient Egypt. I went there for a month when I was 14. I went inside the Great Pyramids. I went into the King's Chamber. I mean, even at 14, I felt like I could feel the energy. I was so privileged to be able to do something like that. And you just stand there and you're in awe. And in my teens and my adolescence, I was absolutely fascinated with ancient Egypt. I was lucky enough to go on a cruise down the Nile and down to Aswan and the Valley of the Kings and do all of that. It was absolutely amazing. But I've always been fascinated by ancient Egypt, and I find it more fascinating that the further you go back with ancient Egypt, they had apparent better technology, and then through the ages, it deteriorated in their ability to do these wonderful things, sort of slowly drifted off into the past, and we didn't really see it again. It always screamed to me that something came, gave them the ability, was there for a while, and then they spent the rest of their time trying to recreate it until the technology failed. They couldn't reproduce it, and then we end up starting again. And before I just let you respond as well, one of the main things that struck me, which a lot of people are talking about now, and I realized when I first saw the pyramids with my own eyes, was the erosion marks on the pyramids, and the fact that it was clear to me as a 14-year-old, 20 almost years ago, ouch, that this meant that the pyramids were underwater at some stage, and that's very much what I thought at that time, and a lot of people are seeing it now. There's so many unanswered questions, and the standard archaeologists don't seem to want to actually dig into the questions that the people have, and I just find it incredibly frustrating.
Yeah, no, for sure. I mean, there's definitely elements there, like the burial of some sites under deep mud. That you can see there seems to be an extensive flooding. That there's a whole kind of a layer of mud over a lot of the site, and then of course the sky mapping. That we've got the as above, so below. That many of the sites line up. You can, again, through my friend, I'm aware that there's basically you can pretty much map the sites, different sites across the Giza Plateau to stars, right? So to the point where if you lay out that map across Giza and look at known sites with their correlations, you can say, well, there should be a site here because there's a star match, but no one's found, so it works both ways, that you can actually then go and look, and he said often you'll go and find and say, there is a tunnel or there's a ruin there where there would have been a star, which is quite amazing. So I mean, they literally kind of they mapped out the the Milky Way as the Nile, and you've got obviously the main pyramids as Orion, but you can go down to like the sites. I was just thinking, so further down from Giza, you've got a site that looks like the Pleiades. There's like
the Pleiades,
structures of the Pleiades. Again, Pleiades and Orion are super important in the ancient myths, both of Egypt, Sumeria, and elsewhere around the
Africa,
world.
even
I would say that actually, in fact, that really Orion and the Pleiades are the most referred to star systems, and after you got Sirius and there's a couple of others, but primarily globally, that those systems come up again and again and again, which again is quite fascinating. Like, what's this about? In fact, one of the oldest stories that's come out from the deep past, from the Aboriginal lore, is the story of Orion and the Pleiades, with Orion the hunter pursuing one of the Pleiades, basically. Right? But if you think about that, that's usually known today as an ancient Egyptian myth.
Right.
But hang on a minute. Why would you have that same representation potentially tens of thousands of years earlier down in Australia? So either there is some kind of amazing coincidence, because when you look up, let's be honest, when you look up, you don't immediately see a hunter and 7 women, do you? I mean, no, by any stretch, right? So the idea that people in complete disparate parts of the world would look up and just say, that totally looks like a hunter chasing some women, you'd be like, No, it doesn't. You like say to your friend, didn't it? Come on, man. What were you taking?
What
when
have you been
saw that?
smoking?
Right.
Let me get some of that, man.
Have you been on the peace pipe again?
Right. So either they're getting influenced from somewhere else, and again, that could be taking psychedelics. You can make the argument that people taking psychedelics were having extraordinary experiences, or that there is an older common core here that has spread globally from some kind of important understanding about Orion and the Pleiades, that they have some kind of importance. And there's a reason why that relationship is portrayed in the way that it is, with Orion being hostile and the Pleiades being more of the, at least neutral, or if not benevolent. And that's a kind of a strange theme. So there's a kind of an idea that there's some kind of difference in the kind of energy associated with Orion and the Pleiades. The Bible also refers to, you got the, I can't remember the exact phrase, but basically who should bind the Orion, and I butcher it, and then to do that. But when you look at the quote, basically it suggests that the Pleiades are moving apart, because it is actually true. They are moving apart, whereas Orion is bound in place. And he says the way it's phrased is as though someone actually understood the gravitational relationships in these regions of space, right? Yes,
we have that throughout history.
It's pretty amazing.
We have the Dogon tribe knowing information about the Sirius B star system well beyond anybody could even see it. There's so many things written in our history.
The Hopi, the Maya, even the Hopi believe that their ancestors came from Pleiades and Orion, and the Maya and the Aztecs. They held Orion's central star as a cosmic marker, and the Pleiades was used. It had a role in their calendar system. They based an entire calendar around that. So it's well, why would they do? You could pick anything up there, and you just so happen to pick these objects and these arrangements of stars that you could then travel the entire globe and see that there's other groups of people that you probably never spoke to that also did the same thing. Yeah. I mean, that's just obvious to me. I don't know.
So you have obvious. Some kind of, we would logically, you'd put, there's some kind of shared cause. So either there is information coming from somewhere else. So whether that's, aliens coming here telling us something, or visionary journeys by lots of shamans who see the same sort of thing, which again would be pretty much as amazing as aliens coming, because then you still got to say that there's a real source of information outside of ourselves in shamanic worlds that tells us real information, or that there is some other deep ancestral knowledge that has come again from an extraordinary way that we just call X way, we don't know, but that we are sharing around the world. Either way, unless you go for it's all just a weird coincidence that all these people are guessing the same stuff, which has been a bit of the argument of the academic world, and which is what's caused a lot of the rejection of the academic story, and why there is a flourishing of lots of different narratives, independently around these questions, because it feels wrong. You intuitively, you hear that someone saying to you, well, we're all humans, and sometimes people just guess the same thing or make up the same story. You're like, it's not convincing. These people are sharing a very precise knowledge. And again, everywhere you go, like you said, the Pleiades rising is the new year. And so you go to cultures around the world, and they're saying, you look to the Pleiades rising, and the fact that Orion being seen as a hunter and the Pleiades as women again, and that theme of the Pleiades as women, again, that recurs in a lot of different cultures. So we have to sort of say that there's some shared deep, at least there's some deep ancestral knowledge here, even if we don't say exactly where it comes from. I think unless you can start off with that, what I'd call basic logic applied to what you're observing. If someone makes another argument, it's really hard to take it seriously. If they start going down the route of it's all coincidences, I think you're like, that's a lot of coincidences there, bud.
Too many.
Too many. And certainly too much, but also I'd add as well that there's connections there with the Anunnaki story, which in my view, the links there again with the Pleiades particularly is very interesting. But there also potentially links with other systems that we've got. These Anunnaki, you can say, is a bit of a catch-all. Those from the sky who came, or the sons of An, sons of the heaven, sons of the sky. Which it's not hard to make the sort of leap that where does a son of the sky come from? Where does a son of the child of the heavens come from? Are they coming from up there? I mean, so even in that base terminology, we can see why the ancient aliens kind of view of it is, well, doesn't it sound like they're telling us that some of these beings are coming from the sky or have some kind of link to the sky. If not that, then at the very least, it's to do with the shamanic sky worlds. Again, we're going into some sort of other dimensional argument, but that they're tied in again and again in these stories, and with the same stars again and again.
With one of the things that I found most interesting, actually, when as I say, starting the deep dive into the Anunnaki, is realizing how much stuff is written down that has later become true. So Zachariah Sitchin calls it the 12th planet, NASA calls it the 9th planet, but there is now suggested evidence that there is a gravitational mass out there in space in an elliptical orbit with the sun that at some point will cross with Earth, and we'll be able to see more. Why they can't get higher resolution images of that at the moment or figure out what that is, I don't know. I haven't got that far yet. But there's that, and then there's the whole story. The foundation of the story of the Anunnaki, for those who don't know, was the fact that they came to Earth because they needed gold, because their planet was dying through industry and massive volcanic eruptions. Their atmosphere was becoming very weak. They didn't have the same magnetic field that Earth has that protects us from the sun, etc. So one of their researchers found that gold nanoparticles in the atmosphere would help reflect the radiation and absorb the toxicity. And then we have recent research here on Earth that has suggested that gold nanoparticles ejected into our atmosphere would, in fact, reflect radiation and absorb toxicity in our own atmosphere. So you've got things like these two examples about the Anunnaki that through modern research we are finding to be true. Now, the chances of those being a coincidence that somebody just happened to write down in a stone tablet however many thousand years ago is what the chances of that being correct? That's non-existent. What's that? A guess? I mean, they're pretty obscure, pretty almost, but also very direct points where you can go, well, hang on a second, this is proven to be true. That is evidence.
Yeah, I mean, the ninth planet connection, the fact that we've got this other planet, what seems to be out there, definitely has been one of the most sort of, I guess, validating parts of that story of there being this other world out there. Obviously, today we're not totally sure whether it's a planet, star, what's going on out there, but there's definitely a gravitational anomaly that is suggestive of a large planet, or even potentially a red dwarf. I've seen it suggest maybe even a red dwarf. That there may be that we might be in a binary star system, and that if we are in a binary star system, that a red or brown dwarf could potentially be cloaked in significant dust clouds. So we don't directly see its light, or at least not easily. So it wouldn't look like a really bright object, that we're seeing obviously a star nearby. That it could be hidden away as a very low visibility object, and you would need to have technologies designed for that purpose to look in the right direction at the right moment to get kind of predict where that gravitational is moving to, because at the end of the day there's an infinite number of directions to look at, so you don't necessarily get lucky just by thinking I think it's there. So it takes a long time of trying to track where you think that's moving, the direction it's moving in, how shrouded it is, how low would the light levels be. So I mean, there's a complexity if it is something like that, like a dust shrouded object. So even if it's a large planet, and again, if you have this issue that it may not be visibly reflecting a lot of light, and again, it may be because what it's made of, and it may be that it's hidden in dust clouds or surrounded by fields of other small objects. But it's I think it's harder to confirm than we might assume, that just there's this big planet or a star. Surely that'd be so easy if it's within the Oort cloud or something that we find it. It's not really as easy as sometimes it may come across the public. So that we do have strong suggestive evidence that it's out there. I'd love to see that confirmed. One of the things I wonder as well, if it's not, do we have maybe even like some kind of dwarf singularity or something really wacky on the edges of our solar system, which again could be a wormhole gateway. Because if it's if we do have that, that would be interesting, because then you've got these stories that supposedly there is a serpent or a spider web that connects Earth to the sky, right? And that it connects us to a web, a great web, right, of grandmother spider's web. So if there is a web of singularities, of wormhole tunnels that is being utilized by some kind of much, much further advanced intelligence, and there are stories from the past of it can send down a web or a tunnel or a hollow trunk, and there's all these different kind of motifs. But what if that is this object? What if we're seeing is the gravitational warping of our doorway into that web, and that's from which the other beings are coming here. And so rather than there being a planet that beings live on, which again is problematic, right? Because how's it getting enough light? How would life have ever evolved there? That if instead that what we have is more like a stepping stone, that there is a gateway somewhere hidden in our own solar system through which advanced intelligences arrive, and that our ancestors have found out something about this and have these many stories. And again, the skyboat motif that we know they seem to be referring again and again to wormholes. And there's an elder, I think it's a Cree elder up in Canada, who talks directly about this and says, what we call this grandmother spider's web, you would call a wormhole today. But that's what we're talking about. And that we have this, our souls came through this gateway in the beginning of time and came down from the web. And there's these really cool stories that come from indigenous people around the world. And like you say, the symbolism and the imagery that we see in many cultures is very suggestive that we are connected to somewhere else. And that's why I tend to think that we may find that it's much wackier than a planet out there, and that when they come through, so not just necessarily one species, but that when species have come through here and they tell us stuff like like a planet out there, they wouldn't necessarily give us the absolute truth. They wouldn't necessarily give us the technical details.
Why would they?
Why would they?
And also, exactly. And it goes back to what I was saying earlier in the fact that, they give it to you based on your current knowledge and understanding. So, it's like you go back and see a Neanderthal and he asks you how your mobile phone works. You're not going to give him the intricate details of how the mobile phone works, are you?
Probably won't understand it.
You're going to have to give it in the terms of which they're going to understand it.
Absolutely.
Bruce, you read my mind, man. You read my mind.
About it. When they say, where do you come from? Again, if you were, a primitive person and you encountered a higher intelligence, so let's say a super advanced alien that looks kind of like a human, like some of these stories, say, where do you come from? The simplest response to that is that star system over there, roughly over there. So you're not going to, we go to planet 6 of this quadrant, roughly over there. You see those 3 stars, Orion, basically there. Another one might say, well, see those 7 stars, Pleiades, roughly there.
But it could be in another universe, another time.
It doesn't mean that that's where their planet is even. That could just be where their jump gate was. So, we came from there to here. But where do you actually live? We're not telling you. You might give that information to another species one day. Why are we going to give you all of the data?
It seems to me then, if we were going to go still down this Anunnaki route, then the story of the Anunnaki, they say in there that we're going to leave for Earth at this time because we're in the right part of the orbit, in which case then we're closer to Earth. So that suggests to me that then whatever it is out there, the 9th planet, 12th planet, or this wormhole, is still in some kind of an elliptical orbit around the Earth. And then if it is a wormhole, then at some point it moves closer to Earth, which means that if the Anunnaki story is correct, they are actually on the other side of that wormhole. And they do not necessarily have the ability to traverse great distances in space, but almost a slightly more rudimental version of that. So that, well, hang on a second, it's going to take us too long to travel from the outer solar system to Earth. We need to wait till this wormhole gets closer. Then we can jump in. Then we can we can jump out again.
It's like when we send Pathfinder, to Mars, we wait for a particular time.
We do slingshots.
Right, exactly. But it could be that on a grander scale. Like we think of it in terms of, planet's a planet. They may be looking at it. It's like, okay, the most suitable time for us to make our jump is when this arrangement occurs.
I've just had a moment. So, what's the movie with Interstellar? Right.
Interstellar.
So Interstellar. Okay. So you've got Interstellar. We've all watched Interstellar. It's actually one of my favorite movies. They go down to a planet and how many years have passed in their 5 minutes, right? Relative to what they've experienced. We're taught that the Anunnaki have a lifespan of 200,000 years.
Something
Go
like
through a
that.
wormhole, come out the other side, go to a planet. Relativity is different. Now, I'm spitballing here, so you can completely tear me apart afterwards, Bruce. But it would appear to us, potentially on Earth, if we had a being that had the ability to do this, go through a wormhole, go to another planet, relativity, time spinning at different relative rates, it would appear that the Anunnaki could potentially have a lifespan of 200,000 years while actually having a much shorter lifespan.
Yeah. I mean, and also just the fact that traveling through time space, you say relativity, that, if they're in some way if there's beings using technologies that are bending time space or that are traveling near light, when you have stories of, say, even in modern contact literature, like if you say that some of the stories of people having contact, whether indigenous people or modern people, when they see the same being, that in the stories, there seems to be the same being or very similar looking being that has appeared, on Earth many times across history, right? And the descriptions of the beings are very similar. Now, it may be that you'd see the same being and think, God, they live a very long time. But
like Thoth.
Right. Yeah. But from their perspective,
he was mentioned 46,000 years ago, essentially in Atlantis, and then 4,000 years later in ancient Egypt.
Yeah. And so you think if any of these beings are traveling in strange ways, that they could really, it's just a factor of warping time space. So the same being comes back and his lifespan, it's not about his lifespan, it's our lifespan, in contrast to the effects of warping time space or moving close to light speed. So that same being can come back thousands of years later to us, but for them it's not thousands of years later. So that you do get into that weird area of science where it's like, yeah, maybe it's not, like you say, maybe it's not about lifespans, it's about the relativity of their experience and our experience, that they haven't experienced thousands of years, that they've had a much shorter gap between being on Earth than we've experienced them leaving Earth and coming back. So that's one of the kind of the interesting kind of paradoxes again about dealing with an alien race, that you might have the same being coming back, popping back now and again over a long period of time, because it hasn't been. I would say that when we get to particularly on the Anunnaki story, though, you have the two factors of problems. One is that, first of all, you've got the person who is looking at the text. So, for example, with Sitchin, then you have to question Sitchin's ability to read the text, which again is controversial. That, I think it's been shown that in many cases, he doesn't seem to have the skills he needed to translate accurately. So you can compare that. But fortunately, the records are all online and searchable. I think it's Oxford Uni, I think it's put them all online. So you can go to the database, you can look up terms, you can look up words, and you can basically go through all of the scanned text yourself. So that we live in an age now where you can do that as researchers yourselves. You can go to that archive and you can cross-reference and decide where you agree with Sitchin and where you don't. Right, which is super useful. The other thing is, though, of course, is that we still have to accept that no matter what, these are just the stories of those people written on those tablets. So it's not objective evidence in the sense that we get to find some, advanced tools, in a mine in Sumeria or something. Or we say, okay, they said that they were mining for these gods, and here we found a laser tool that is hundreds of thousands of years old, and therefore the story is validated. So, I mean, initial stage, you're just like seeing if the story you're told meshes with the story they told. But then once you get to that layer, what you really want is beyond that to show that their stories are real. And that's a major problem whenever we utilize, say, ancient culture and lore. It doesn't matter whether it's Sumerian or Babylonian or Egyptian or Mayan, that what you really want is to then be able to go beyond that and say, and there's extraordinary knowledge they had, which they couldn't have had, which has been validated. And there's art, ideally, there's physical archaeology, objects, things like that validate it. And that's where it becomes very difficult, because in most cases you're getting very little of that, if not none, right? So it doesn't really matter which culture you're looking at. So you can say, okay, these native people in America are saying that beings from the Pleiades came here. Really cool story. Some of it meshes with, like, what we were talking about before, like the idea of wormholes. but that doesn't mean it is a wormhole, right? You know, so do we get any radiation traces of wormhole opening, or do we get an artifact dropped by the beings where they can say, well, look, but we've got this, you know, this tool that we shouldn't have had. And so that's particularly why, you know, I focus in the area I do, is because, you know, it's the only area of these kind of topics where I've been finding like objective support. So I think the stories that we get from these cultures are really cool, and I think they make really good visual like you know, projects. Like, so if you like say make a project like you're doing, we'd say telling an Anunnaki story and doing your best to see that the information you're getting firsthand from the people, you know, it meshes up to what is being publicly told through different books, you know, obviously from Sitchin and other people that have covered the Anunnaki. And there's lots of different researchers now that are written on the Anunnaki kind of hypothesis. So you look to see as much of as possible that you're cross-referencing with the ancient sources first, and then also seeing in ancient sources, you know, what additional evidence has come up in recent years that might indicate there was some advanced technology. Because like if you look today, how, you know, just talking about mining, because one of the things that comes up a lot is the idea that perhaps humans were made to mine, right? Well, we use large robotic mining vehicles today, right? Which can go in and, you know, we use blasts, you know, we blow up a mountainside, you can send in robot trucks and stuff and robotized digging vehicles. So you have some people overseeing that, but a lot of the work today in a modern mine is robotic. So then you have to ask yourself, well, if you're an advanced species, like, wouldn't you be using large-scale robotic vehicles? Like, if you can travel here from outer space, surely you have at least our current level of technology, right? At minimum, right? You'd think, because like we haven't managed to get even beyond Mars, really. We haven't landed there, but we haven't really traveled the solar system or something. You know, we're just trying to get our technology onto Mars, you know, the moon and stuff. So someone has done better than that, should have technologies for mining that outshine ours. They also should have noticed that we have a richness of rare metals in the asteroid fields, and that, you know, it's easier to crunch up an asteroid than potentially do large-scale mining on a planet surface. So when you get to these kind of issues, you've got to say, well, what is going on here? Is it that we are not getting the full translation? Is it that there is a misunderstanding by the people themselves when they write these stories? Is there some other, you know, aspect to this why we're not seeing that evidence? Because we should be able to see something that's been chopped up by a laser, for example, you know, that if it's been sliced, a mountain sliced in half with a laser, or, you know, if there's really advanced things happening, some of that should be traceable. And why is it if when we look at the dig sites, if we only find primitive Stone Age tools, you know, why would you get a workforce to work for an advanced race and give them pickaxes and not say, well, here's the robot mining tools, you know, you guys operate them? And would none of those ever get dropped? Why don't we ever, you know? So I said these are problems we have to be able to answer.
I think, first of all, I think there are examples of the results of tools, not the tools themselves, but there are the results of tools that we can't explain. So there are instances of, you know, rock formations and rocks being cut in certain ways that we don't have the ability to even do now. We don't have the tools. In Central America, there are rocks that almost look like they've been molded together, but, you know, it's clear they've been cut, but we don't have the tools. And we, even with these bowls that were found in Egypt, right, that are out of granite, that are completely spherical, and there was no way that they could have made them, yet we haven't found the tools. Now, Tom and I were talking before the show, and I sort of brought up the whole sort of Star Trek Prime Directive sort of hypothesis. And I said, well, what if you've got sort of like a retrospective sort of Prime Directive thing in play here? What if a race, not necessarily saying the Anunnaki or whoever, but came to Earth, influenced our DNA, our makeup, and made us who we are today? Whatever happens throughout history, and then they go, actually, look, we need to leave. This, you know, this has got to a situation where we need to step back. clean up shop, get rid of everything that's ours. You know, I mean, God, I mean, our own government has the ability of telling us where our cell phone is, even if it's been turned off. You know, so to say that an ancient civilization should have left something behind, you know, you don't know what technology is available, you don't know their ability to clean up shop. And then you look at something like the Anunnaki, where it has threads in all modern day religions. And what I said to Tom was, what if modern day religions are results of them going, we need to leave, we need to clean house, clean shop, and go, right, well, let's push them in this direction. Let's give them this religion, let's give them this doctrine, and let's let them sort of find their own path and try and erase ourselves from history. Because there are so many things that don't make any sense, and we're just left with the questions, and there don't seem to be many reasonable answers that tie it all together. And I've said it a couple of times over the last few weeks, and that is, it's all very well and good us looking to, you know, all the UFO celebrities out there, and everybody confessing things to Congress, and David Grush and Jake Barber and everything, and it's great, and it's great entertainment.
Sure, yeah,
it is. Yeah. It is great entertainment, and I don't mean that as an insult to Jake Barber and David Grush and people like him, because I really respect what they do. But they've been allowed to come out. If people wanted them shut up, they would be shut up. They're being allowed to speak. They're being controlled whether they realize it or not, because it's entertainment, and it goes back to the Colosseum, give the people what they want. So I truly believe that instead of spending all of our time looking at modern day crash retrievals and whoever's coming out on the next documentary, we should really be focusing our attention, which is what you do, on the past and where we came from, because I think that actually that holds the answers, and that's where citizen research and journalism can get involved and actually potentially answer far more questions than if people are being abducted or the US government have a crash retrieval program.
Yeah, absolutely. If you think about it as well, one of the repeating kind of claims or memes, but certainly claims in the field, both in, I'd say, in the UFO world and the ancient aliens world, and amongst many of the same kind of influencers that we'd be thinking about when we talk about this, they have referred to DNA as being where they just think we should be looking. Like, that's come up from a few different kind of very influential people in these topics, as well as in ancient aliens, but as well as, of course, across nearly all of the ancient aliens researchers would all say, you know, that we should be looking at DNA, and it's a recurring thing. One of the things I find that's kind of funny about it is that although it's a recurring thing, like if you think about all the different influential people, you know, I don't name everybody, you know, so there's, you know, if you say there's 20 odd people really that get most of the eyes on their work in the UFO and ancient aliens world, right? That none of them really have offered an in-depth discussion on the anomalies in DNA. I mean, apart from myself, I'm not saying that as it's just, you know, I'm so great, but I do find it strange, you know, like for example, when Tom DeLonge's book came out, you know, the God's War Men series kind of thing, that I was a bit nervous because I thought the second book, they will be covering the same kind of topics I cover, you know, saying, you know, about manipulation of human DNA and stuff was going to be in there. But in the end, there was very little. And I thought they were going to get ahead of me and almost like scoop me, you know, they're going to, because I was doing similar kind of research. You know, you're thinking, well, you know, these guys have got a lot more money, access, scientists, that they certainly can access all the same papers that I can read, you know. So I was kind of thinking that they're going to go in hard and we're going to see all the anomalies and it's going to be like, you know, aliens have manipulated us, but it didn't. And I've not seen from then to now any of these kind of influential people actually say, well, let's sit down and talk about the anomalies in DNA, because we've all brought it up. It's a super popular kind of idea. It's been on loads of different documentaries. But what are these anomalies? You know, like, is there evidence that someone's done this, right? And I know that's what we've been talking about, the fact that there really are. And like, I jumped a bit back here because what you were saying there, Digby, is that, you know, these are things that anyone can do. The reason I say that is because if I can go and read a paper, so can you, you know, so can Tom, so can everyone in the community. These are not I'm not going to like my secret source who whispers in my ear that Bruce, there's this anomaly in the genome. You need to look at gene 7b. It's not that you can go through the released genetic studies, particularly if you have kind of focus on, say, like, you're interested in what made the brain the way it is, or what made us different from other hominins. That these are questions anyone can ask, and then go and look up studies. I'm not saying that studies are always super accessible, because sometimes you have to find a way around paywalls. You have to sort of use websites that allow you to access that information, or do you have to email scientists? So I'm not going to say there's no effort involved in your part, but it potentially, any citizen scientist or citizen journalist can actually do that. And we've not really seen that in the community. And I don't really understand why, because I'm not some sort of lone genius who knows so much about the genome. Again, I had to read the same stuff that anyone else would have to read to get to this point. I just had to read these papers and read these studies. And the other thing is
though, Bruce? I think that people don't know where to start a lot of the time. People go, do you research? Sometimes. And I'm like, but where? Where do I go? What do I do?
Yeah,
they look on X.
I started at DNA, because that's where I think the anomalous. So, like, what ancient alien and ancient astronaut theorists are very good at, and I think even Digby and you yourself, Bruce, are probably good at this, is taking things that were written by people many millennia ago, or however far back you want to go, and you're able to look at it through a modern lens where their language was limited. So, like, a good example is like this incident where the Roman army was trying to cross a river. Jacques Vallée writes about it in Wonders of the Sky, or Wonders in the Sky, and they talk about this like metallic gray shield coming out of the sky. I'm like, okay, it's a flying saucer, right? So I'm able to look at that. We're good at doing that. And then I try to take that and I'm like, okay, so if there was genetic manipulation going on, then there must be some sort of mention of that, but it's not going to be written the way that we think it would. And and there are examples of that. And one of the examples that I use, and I'm sure you're probably aware of this, but it's in India, the Vedas. There's the Vedas, there's the Puranas, and the Mahabharata. So the Vedas refer to the concept of the primordial being, Manu, created through a deliberate act of divine engineering. And then there's also Karna's birth. Karna's birth is in the Mahabharata and was born through a mystical process that, when looked at through, again, a modern lens, it sounds like in vitro fertilization or gene manipulation.
Well, Tom, this goes back to what we were talking about before the show, is how many religious texts speak of the birth of humanity coming from the blood of a deity and the clay of the earth, or the tear of a god with the clay of the earth.
Absolutely.
The clay of the earth meaning actually just the base formation,
genetic material
already here, mixed with something from above.
Yeah, it's a repeating theme. I agree with you saying, Digby, that sometimes people don't know where to start. And it's because, again, I suppose I had the advantage that my previous book was on, human origins and the early migrations and stuff, so Forgotten Exodus, the Inter-Africa theory, which is nothing to do with aliens. But it meant I'd read the literature, quite widely on the various hominins and, what was happening with them. And so certainly I came into this project with a wider knowledge than I think probably anyone else in the UFO or aliens field would have, because they're not. Right, because they're not particularly focusing on hominins. It's not. It's not something else.
That's understandable. It's maybe not as interesting.
Right, because it's not their pet project. Because they're doing UFO studies or whatever it is they're doing. Right, their own area, maybe materials analysis of UFO debris or something else. But they're really interested in. But because I already had that, and I had a knowledge of the kind of hominins we have, their relationships, and when they kind of appear. Obviously, that is super helpful. And also just a familiarity with reading academic papers, because let's be honest, there's probably a large segment of the audience here and, UFO Twitter who may well have never read an academic paper, because they're not exactly I wouldn't have done. They're not super entertaining. So
going into this area is a lot of people's first sort of foray into thinking for themselves and thinking certainly thinking outside of the box. This is the
or
first
heavily
time
scientifically,
I don't agree with what everybody else is saying.
Right.
And so it's the first time that they've ever been presented with a situation where they sort of need to do that sort of research.
Right, to dig and look at primary sources and say, is the scientist telling me the truth? Do I trust these authorities that have told me this story? Should I take a step back and say, did hominins really evolve in that way? Because we're so used to just, those articles will come out, tell us what's happened, a summary of the new discovery, and it files away somewhere into our unconscious and we move on. But so unless you say, well, actually, I have some level of conflict with what's being told to me, maybe this is a mistelling of the source paper, and you going and reading that yourself, you may well find sometimes, it does actually turn out that what you've been told is a misunderstanding by the journalist, or something like as simple as that, that they haven't understood it properly, and that you're better off checking the paper. And also sometimes you read through a paper, and I would advise this for anyone who does it, read the introduction, like the summary, and read the conclusion. Always. And then you'll find out from that if you want to read any more of it, because that will give you basically, this is what it's about. This is what we concluded. If that's interesting enough for you to then think, well, how did they get to it? You'll go back. But if you read those two sections, think this doesn't really refer to what I want to know, or there's nothing here that sounds so out of the ordinary that I'm likely to want to read 20 pages, so you can save yourself a bit of time. Don't be frightened for people that are listening. Don't be sort of frightened that, oh God, 20-page paper, I'll just get the summary from someone else. Because if you just start with those sections, you'll get a good idea, and then just skim the bits, look through the subheadings for bits that you think is relevant to your question and what it is about that study that you had a query on. Do you know what I mean? You don't have to think, I'm going to have to put 100%. Time aside for a 20-page paper. With AI, of course, you can even get the AI to summarize it for you.
Absolutely.
Right.
It's very helpful.
Yeah. So we've moved forward into a different era for that. The other thing I was going to say, though, if we can ask questions, if you want, I can give you some more of the anomalies and why I say that there is.
Yeah. Why don't we get juicy, Bruce? Because there's. I do have a question. I'll save it for in a little bit. But yeah, why don't you go into the weirdest of the weird here? Like, even if we get super speculative,
I think we're going to have to make this a two-parter actually at some point. I need to go feed some children dinner, but
how much time
do you have? So I don't want to derail.
I've got about 9 minutes.
Okay, so you might need to do a follow-up. So in that case, I'll introduce.
Absolutely, we can do a follow-up.
No problems. I'll introduce where we're going with it then, and a very basic, and we can always come back onto it.
Sweet.
So there is a kind of a guidance to if there had been manipulation of humans, or if there had been a deliberate message encoded in our DNA. So there is some guidance on where we'd look for that, and the reason is because obviously it's a valid area to look. This thing called genomic SETI is the idea that an advanced alien race could come here. It could have been long ago, encoded a message into the genome of a species. It doesn't have to be us, but just a species on this planet that is there, so that once a civilization emerges here and has the technology to look at genomes, that it would eventually find this message, this signature in the genome. It could be in all species, it could be in just a species they expect us to look at one day, or in us. Right. So that's not woo. That's that's something that has been considered as a possibility by a number of academics. But the counterintuition to it has been that the idea that, well, evolution could sweep away messages or information that relates to such changes. But this is if those changes are in genes, particularly, because genes, they're adapting, right? Genes are changing, we get mutations, and we would say slowly in terms of our lifetimes, but quite fast in terms of geological time, right? Evolutionary time. Right. That over hundreds of thousands of years, certainly of millions of years, that the encoding or manipulation of genes could be impossible to see. Now, so you used to say, well, where would you look? Now, if you were an advanced species and you knew that that's a problem, where would you put changes? And again, this is a dual thing, that this can be deliberate changes or just scarring, signatures, traces of deliberate manipulation. They're going to look pretty much similar to us. We just want something that would still be there and looks anomalous and looks like it's the handiwork of an advanced species. So it turns out that there is an area of the genome that's called highly conserved or super conserved non-coding information. So this is when you go into what used to be called junk DNA, right? So today junk DNA is no longer considered junk. We know that a lot of it is active and is now considered to be non-coding because it doesn't code for genes, but it does mostly regulatory functions. So in other words, it regulates the expression of genes. So whether a gene expresses what we call strongly or weakly, or if a gene is turned off or on, these genetic switches, most of those are in the non-coding information. Right. So in there, you also have segments that are considered to be highly or super conserved, because when you look at these sequences across all species, like across all mammals, for example, right, you'll find there are some sequences that are identical, right, across a wide range of mammals, or very close to identical. So we know that they have remained structurally the same for tens or hundreds of millions of years since the diversion of all these different species, right? Divergence, sorry. So you've got some that we know are hundreds of millions of years old. The one I like to give an example, because it's very straightforward, is there is a segment that was detected in humans. It's about, if I get it right, 118 DNA letters long, which is quite short compared to, say, genes. So it's quite a short segment. And they found the same segment in chimps and us and compared them. And they also compared them with chickens, because chickens diverged away from chimps and humans about 300 million years ago. Okay, so that's a nice gap. So you've got this 118 DNA letter sequence in chickens. They compared it to chimps, and they found that 2 letters had changed in 300 million years. Okay, so now you've got a mutation rate of 1 change per 150 million years on average. Super stable, right? Super stable. So it has to be doing something really critically important, where mutations usually lead to the organism dying. Or certainly it can't reproduce. Okay. And then when they compared the same sequence with humans, they found that between the chimpanzee and the human, that 18 letters had changed. So this was totally unexpected. So now these are called human accelerated regions, where the evolution seems to have been sped up massively in a very short period of time. Remember, this is in about 7 to 10 million years. So the expectation was 0 changes. There should be no changes. And instead, we find 18 letters. So the rate of evolution was sped up so much that when they created a biostatistical program to kind of understand what was happening, and it came to the conclusion that there was functionally a 0% chance of this happening by any understood evolutionary mechanisms.
Wow.
So they're still debating these HRs now.
Is this the FOXP2? I don't mean to cut you off.
No, FOXP2 is a gene. So some of these genes are weird, FOXP2 included, but these are not genes. So again, these are just code, information behind genes that are switching on genes, turning off genes.
Right. Okay. So it's like they're
right. So this is what they call regulatory functions, right?
Gotcha.
So we now have several hundred of these human accelerated regions, and all of them have what we would think of as accelerated evolution. Right. The other thing about this, very quickly, is that when you think about random evolution, right? Random being totally random, yeah. So what they found is that of the understood HARs, something like over half of them relate to our unique brain, and that they are considered to be one of the key areas of code that make us different from all the other primates. So when you say, like, you look at the chimps and you look at the orangutans, and people say, oh, we can't be, so closely related to them. What makes us look so different and behaviorally so different? And it turns out most of that is in these HARs, right?
Wow.
Particularly the brain functions that are unique brain functions. Most of them trace back to these strangely accelerated sequences of regulatory code, right? So they're not very random. If like over half are to do with particularly fetal brain development, so in the fetal stages of the brain's development, that they are making critical changes to brain structure that lead to us, right? They've also found that it's not just acceleration of code that's been important, because again, this is in the last couple of years. This is like really new stuff that's still happening, cutting edge stuff. They found that there are large chunks of regulatory code missing that is in all the other mammals. And I recommend the Zoonomia project. If people want to check, the Zoonomia project has been comparing mammal genomes across the mammal kingdom, right? And so what they found is that all these other mammals have these segments, basically, their normal kind of rates of change. And they found that there are chunks of code missing in the hominin lineage. They said, well, this should be like really deleterious. There should be a massive problem. Saying basically, should we even be here? Because if these segments are so important that they're static in all the other mammals, how did we survive them vanishing? And why did they go? Why have we lost chunks of code? And they found, well, the other thing is that instead of causing a problem, so it seems like where this code vanished, it allowed interaction between other sequences that were really important for the brain to develop. They said, again, this was totally unexpected. This code should be there. It should be there. You look at all the other mammals, it should be there.
I was just going to say, what comes to my mind is what you were saying earlier, is if somebody wanted to leave a message in our DNA, in our genome, then it was difficult to do that, because if you added something, it could be bred out, right? As in,
yeah, so it's the genes, yeah.
But what if it was easier to delete something and the code was actually in something that you can see has actually been taken away? Because then that wouldn't be replicated through breeding or anything like that.
Yeah, well,
so what if it is actually what's been taken out, what's missing?
Right, well, both, really. Basically anything you do in those highly conserved areas would be a functional message that you've been there. Because, again, they shouldn't be either accelerated or missing. So if you see a change like that, straight away, that should be a red flag. Like if you were just going out, you say, you're going to start in today, right? I'm going to do SETI, genomic SETI, right? That's your project. I hand you your budget and you say, okay, well, I'm going to look for a message in the genome. Your starting framework would almost certainly be, well, I need to look at areas of the genome that are super stable, because we know that genes will be changed and those messages would be swept away. So you'd almost immediately, you'd want to look in the highly conserved regions. And so the irony is, here we are seeing that in those highly conserved regions, we have anomalous acceleration and anomalous deletions. And there's no red flag going up here from anyone in the SETI world saying, but that's precisely what we would want to see. Now, it doesn't mean that you've proven aliens did this, but what it does mean is you've hit that first level of where you found the signal, right? Where you then want to see if the signal holds up, right, to further scrutiny. But we are living in a situation where no one's even raising the flag and saying we found the signal, that the wow signal, the original wow signal, this is the wow signal. So then they went on to determine, was the wow signal from space or was it from human technology? So you have all these other processes you'll do, right? But the thing in genomic SETI is no one's even raising the flag and saying that we need to look at this closer and consider whether it's actually been done and whether it's a message, whether it is indications of an advanced civilization. And I know you haven't got long, but I raised another thing. This is really something that I was really lucky with. Was a few years ago, Mick West was interviewing Chef Shostak, right? You probably know Chef Shostak. Most people out will know him because he sort of poo-poos UFOs a lot, and he's the guy from the SETI Institute that kind of, whenever they want to ask a skeptic about UFOs in the SETI world, they wheel Chef Shostak out of his office and he kind of poo-poos it all and laughs about little green men and stuff. He was on Mick West's show, and I managed to get a question asked to him, and I was so pleased because I don't know if I'd have the opportunity. And so he asked him, was genomic SETI a legitimate field, basically, and like, should people be doing it? And so he was asking me, oh yes, and the esteemed scientist Paul Davies has talked about this for years, saying that we should have someone just look and see if in the genome that there's any evidence of a encoded message, and that probably a grad student could do this in a few weeks and stuff. But as far as I know, nobody's ever done it. And I thought, you're sitting it. You're the face of the topic. You've got a whole institute of people. You've had millions and millions, tens, hundreds of millions of dollars pour through your institute. And you're saying that you haven't asked a grad student to do a pet project, that these people would line up for you. You're the SETI Institute. And they've never even thought, we'll just task some volunteer students on this for a few weeks. He's saying it's totally a valid area of science. Top people have suggested it, and none of them have bothered. And I'm having to do it in my bedroom at home. And I thought, this is absolutely, it's offensive to science. It's offensive to the
You're absolutely right. And you know what? No, but it's okay, though, because now you can do it, Bruce. You don't forget about it. They gave you room to do it.
I shouldn't have to. I mean, it should make people stop and think, why couldn't they do that? They're spending all these colossal amounts of money on listening for a signal that no one believes.
AI?
Right? No one believes.
Oh my God.
That signal.
You could put AI to serious work over this. And once you blend it with quantum computing, obviously within maybe like the next 5 to 10 years, the amount of data that
that'd
you
be
could
done in
actually
2
go
minutes.
through, it would be insane.
Well, this is the thing. I think that now we're in an era where if we get the right people to do the AI to go through all the genomic studies, that I don't think it's going to stop at the the brain expansion, the HARs, the H-condyles with the human conserved deletions. We also do know, I say quickly as well, that there's a 3-dimensional genome folding event, which is a singular event. And again, this is important, not slow changes, that there is a singular event that occurs where the human genome refolds 3-dimensionally, allows areas again to contact each other that causes brain changes. And it's agreed that that is in 1 generation of humans, not over time. They said we don't know what it is, and it's inexplicable reconfiguration of the genome that gives us our brain in 1 generation, either a single egg or sperm or fetus. So that's exactly what you'd look for engineering. And nobody's putting the flag up and saying it really looks like we're actually finding tangible evidence that potentially is the genomic signal from an extraterrestrial intervention.
Oh my God.
And I have this in my bedroom. I mean, I'm fortunate I have some collaborators now, but it is, I find it angering to a degree, because I know that there's these massive academic institutions, and they have the funding, they have labs, they have dozens and dozens, not only their own scientists, but grads who would line up to do projects with them. If they put out an offer and said, we want 20 grads in genetics just to do a small project with us, to go through some studies, see what's what I mean. So it's absurd that it's been left like this. And I'm fortunate in that I have a few collaborators, but it's not the same as if I was sitting in Steph Shostak's shoes and I thought, well, let's really do this genomic SETI, because radio SETI hasn't panned out, right? We've poured money into it. Nobody really believes it's going to pan out, because the mathematical odds that you're going to have a civilization out there that existed just at the right moment to send out radio signals, which is probably a brief period of time in its technology, that happens to go towards our star at the right moment when we're listening. Like it's the needles within mountains of needles, in oceans of needles, is the chances of picking up this message. So most of the kind of SETI world is now moving towards other things, right? They're saying, let's look for megastructures, let's look for signatures in atmosphere,
which is fine.
Yeah, which is great, because that should have happened years ago. Let's be honest, it should have happened decades ago.
100%, easily.
But now, the one thing they're not doing though is genomic SETI, right? They still
this
not
is
doing
huge. You just made the most convincing genetic argument I've ever heard in my life. Like, I'm serious. I've been researching this for a very long time. And I'm especially with the new stuff, I'm just like, oh my God, we gotta follow this. This cannot be the first discussion, podcast, video, or anything that Digby and I do on this. I mean, that is just
no. Well, I think we're going to have to go for a part 2.
Easily. But that's okay. That's good. That means there's meat on this bone here, and I'm ready to chew it. I think let's do it.
You see why I spend so much time on it, and why I'm like, this is really 100%. A real project.
I wish I could chew the fat with you for another 2 hours, but I'm getting messages from my wife going, the children are hungry, and they're currently locked out.
They'll be fine.
I have that. Don't worry. I've upset my wife more than once by going over on podcasts and everyone's waiting to do other things, and
the girlfriend's sleeping.
But look, Bruce, I'll reach out to you after the show. We'll get part 2 in the diary, and we'll get it advertised to people. Actually, to be honest with you, once it gets past the 1.5-hour mark, I think if there's more to say, it's better to go into another show anyway, because it makes it easier for people to watch.
Absolutely.
It's been an absolute pleasure speaking to you, and I can't believe it's been taken this long for us to actually get round to talk to you. We should have had you on a long time ago, but
very much
all things in the order that they are meant, I guess. But it's been an absolute pleasure speaking.
And that's his website as well.
Yep.
Thank you. No, it's been a pleasure. And, I think the time is good. I think also, not being funny, that the kind of collapsing of the main narrative is no bad thing for me, because obviously I think people are going to start looking at some of these other projects that are out there that aren't just, insiders going to bring out something. And as you guys have both touched on, is that we need these independent efforts, not just mine. There's a few others that I think now that as people realize that you can't just wait for the government or for the intelligence community, let's look at some of these projects. Let's do some of this work ourselves, collaborate on independent research, and that there's really interesting stuff out there already that's getting kind of sidelined. And so I think, it's good times ahead.
It's good science. It's real good science. This is exciting. I can't wait for part 2. Part 2 is going to be a juicy one.
No, I'm looking forward to it. On that note, I do have to go. So, Bruce, thank you for joining us today. Tom,
yes, thank you very much.
And
thanks for everyone who listened as well. Appreciate it.
Yeah,
you know.
Definitely.
Thank you for everybody watching live, all 579 of you. That's a good number.
That's a really great group.
It is. Thank you all for watching us live, and if you're watching this on repeat on YouTube, thank you. Please hit that like button, press subscribe, share with all your weird and wonderful friends, and help us keep this channel going.
And go to that website right there, alientechnosignatures.com.
Go to that website and follow Bruce on X as well. You can find him. Just type in his name; it'll come up. So from me and from Tom, until next time, take care. God bless and goodbye.
Thank you. Bye-bye.
Cheers, everybody.